Assalamualaikum warahmatullahi wabarakatuh. So today, let me introduce myself first. My name is Wasafran Aiman Bewayami. So today we will present project for the subject electric graph. Okay. For the title for our project is Closed Loop Speed Control DC Motor using PID controller for conveyor. So for the project background, as we know, today's system of conveyor is one of the common type of handling equipment that's allowed to transfer material from centers place to another. The system of conveyor is considered a faster and good effective of transportation that can use for the various user of things, which can make them most familiar in handling material and industry information. Several types of conveyor system today are available and they are skillful that based on the demand of different of manufacturer. In status operation in the evolve the conveyor operation lower down or faster up of conveyor during the adding load or thing and during the decrease of load that can effect of timing process. It will change to the new format and the set speed will be the second input by using the rotary auxiliary from the DC motor. This process This process will go on until the speed of motor starts. For case when the error is becoming or almost to zero, by using MATLAB or simulation will show the performance of PID controller. And PID controller also an open source platform for building project electronics will be used as the controller for this project. The proposed system using PID controller scheme is designed on MATLAB and simulation performed on simulate platforms. That's all for me. So next,
Okay, my name is Muhammad Hanafi Adli bin Masobli. So I will present about objective and analysis. For the objective, simulation-based variable speed DC motor drive by using simulating software to identify the output of the developed simulation lab in software. And lastly, we need to determine the fundamental and design closed loop system. About the analysis. Before starting at the full speed, the DC motor must be run down with a very low speed. The thyroid is required in this scenario to control the speed of this motor as well as the firing angle of the control circuit. The only component that allow for phase angle control of the power output is the thyristor. The motor generates the greatest power in the active early in the half cycle, while late trigger produce the least amount of the power throughout the half cycle. Effect is similar to that a very fast switch can be triggered and conducted in a half cycle at an infinite number of sites. The efficiency of this method of power management is very good as the thyristor can control a great deal of power in DC motor with a very little energy. Utilizing a thyristor to control the speed of a DC motor is a particular advantage since it avoid the issue associated with the management control technique. So I will pass the next slide to my friend.
Okay, hi, my name is Muhammad Nurazin bin Hayadin. I will present about the methodology. First thing is the system design. In this project, a closed loop system is being used to control the speed of DC motor for conveyor. The reason using closed loop system is because the closed loop system more accurate to generate value in the project is the speed control of DC motor, its ability to reduce the system sensitivity to external disturbance. And second is in the system design, there are 5 components that have been used, which are DC machine, DC voltage source, PID controller, motor voltage control, and control voltage source. The function of a motor voltage control is
Rakibin, you order.
control or set the speed of the DC machine and the system design. A motor voltage control is preferred because high efficiency, good response and good response regulation. Next to the software. In this project, we use MATLAB software is being used to simulate the project design and produce the result to complete the assignment. In the system design, there are MATLAB block parameters that have been used to complete the system design. Constant value block parameter is act as the amateur voltage control to control the speed of DC motor. The bus selector block parameter is used to convert the output signal to speed Wm rate over S. The gain block parameter is used to convert radian over S to RPM. To gain value is 30 per pi because 1 rate per over S equal to 30 over pi RPM. The add block parameter is used and subtract the input scalar more than or equal to 1. Specify the number of input or the sum. Scope is used to show the graph result of the simulation. Next for working principle.
Okay, my name is Muhammad Amir Amirul bin Elias. I will present about the working principle or the operation of this project. We use a PID controller for this project, which is stand for Professional Integral Derivative Controller, used as a control loop feedback mechanism to control process variable and are the most accurate and stable controller. PID controller is an instrument used in industrial control application to regulate temperature, flow, pressure, and speed, and other process variables. Industrial conveyor are always being used, and the main part of conveyor is DC motor. PID is being used to control the speed of the motor, of the DC motor. PID controller have higher stability, no offset, and can be used to reduce overshoot. The working principle behind PID controller is that the proportional, integral, and derivative term must be individual, adjusted, or tuned. Based on the difference between this value, a correction factor is calculated and applied to the input. Proportional tuning involves correction a target proportional to the difference. Thus, the target value is never achieved because as the difference approaches zero. So to thus the apply correction, integral tuning attempt to remedy this by effectively cumulating the error result from P action to increase the correction factor. Okay, I pass to my friend.
Assalamualaikum. My name is Muhammad Azizi bin Izzat. So I will show the simulation for this project. For the initial result, we get this graph. This graph has error because we get to 1,450 in 3 seconds. So it's very late to achieve the speed. So to fix the error, first we need to go by it and change the PI value to get the accurate number. To change, we need to use the PID. We will and get the graph. We get the graph in the PID. This is the plot response, is the error, and this is the true response. And we can get the PI value in the true, which is the error. So we update the block. And we get this accurate graph for the speed. So you okay, we run again, and we get this very accurate graph in the course of 20 seconds. We get the distance in for the speed. To adjust the speed, we just need to change the value at the amateur voltage control. So, example, we choose 1000. So, one and get at 1000 in 0.2 seconds. The speed is constant until the system is shut down. So, that's all from our group. Thank you.